Hello everyone, my name is Vikas and my topic is today is on priority scheduling with aging and no aging. Introduction. Operating system scheduling on aging, priority scheduling, and every time the unit ready processes with the highest priority runs if a newly arrived process by as a higher priority. It preempts at the running process. If the scheduler decides which process runs on the CPU next to maximize responsiveness, throughput, fairness and mixture. Experimental setup. In this we have used the coding language which is Python. Tools used is Python 3 and datasets which is 3 mixed. First one is mixed arrivals, starvation prone scenario, and last one is larger mixed. In mixed arrivals we have used four processes, and in dataset 1 which is starvation prone scenario we have used that also 4 processes, and dataset 3 that is larger mixed. For larger mixed we have used 5 processes. Next one, implementation setup. First one is step to step procedure. In that we have used first one, model each process with fields, where it contains PID, arrival, bus time and etc., which simulate the time unit from T0 to process the finish. At each time newly add processes which will be added to the ready list, which will be incremented each ready process, weighted, counted except the one currently running. If the process is weighted which is greater than equal to aging threshold, the aging will be enabled and reduce the process by 1, and it will be reset weighted, and the ready process will be selected with the smallest priority value. Fourth one is at the end the process waiting time, turnaround time and response time will be with the context switches. Flowchart, here we have to start, then we should initialize the process list. Next, t is equal to 0, then loop will start until the process will be finishing. Next, we should add the newly arrived processes to ready. If the ready is empty, CPU idle will be unit 1 T++. Otherwise, else each process is ready, it will be weighted, aging will be enabled and weighted will be greater than threshold priority. Then we should select the process with the priority. Then after that end loop, then compute matrices, then we have to stop the process. Next is the code. Here is the code for the Python which is used by the Python coding language. Next is the console output and Gantt chart. First, for the data set 1 with no aging, the average waiting time is 4.50, turnaround time is 8.50, response time is 3.50, and the context switches is 4. With aging, average time will become 5 due to this threshold aging is equals to 3. Next, the average turnaround time is equals to 9.0, which will be greater than no aging. Then average response time is 4. Context switches will be 5. Next is dataset 2 with no aging. Waiting time is 0.75. Next, turnaround time is 4.00. Then average response time is 0.00 with context which is 4. With aging also it has the same values with which has from no aging. Here in the data set mixed, the processes with no aging, average waiting time is 6.80. The average turnaround time is 9. Average response time is 5 and content switches is 5. But with aging, the average waiting time is 5.20. Average turnaround time is greater, which will be lesser than turnaround time with no aging, which is 8.40. Average response time is 5.20 and context switches is 4. Next, the observations. Here is the observations. First one is the waiting time. In the waiting time, the average aging on both increase and decrease will be waiting here depending upon the workload and arrival patterns. It may cause promotions and promotions according to the short high priority. Jobs may wait here. Next, turnaround time, which follows the waiting time trends. Response time, it will affect the first response time if promotions change and first schedule process. Context switches which increases because priority premises introduce more permission. But in some pattern, aging reduce context switches by letting some jobs finish earlier and avoid repeated permissions later. Starvation avoidance. Aging successfully prevents indefinite starvation in scenarios where low priority processes would otherwise be continuously permitted. Next one is here is the comparison table, evaluation table. Thank you.